Hello dear students, how are you? You are all doing very well. Today inshallah we will continue our lesson about oxidation reduction reactions. But today we are not gonna take a new lesson. We're gonna just practice some problems about how to assign the oxidation number for certain ion or atom. So actually I want to make sure that you all understand the previous lesson, because without understanding the previous lesson we actually cannot move further, because the lessons that will come next, they all depend on this lesson, so please be careful guys. So last time, if you remember, we start our discussion about oxidation number. We say that oxidation number assigned to an element in a molecule is based on the distribution of electrons in that molecule, and then we moved to the rules for assigning oxidation numbers, and actually these rules are so important, and today inshallah we will know how we can use these rules. Then we moved and we defined the meaning of oxidation and the meaning of reduction, and we said oxidation is reactions in which the atoms or ions of an element experience an increase in oxidation state. So whenever there is increase in the oxidation number, then the process is considered to be oxidation process, while in reduction there will be a decrease in the oxidation number, and so whenever there is a decrease in the oxidation number of certain ion or atom for an element, then this reaction is considered to be a reduction reaction. So in reduction reaction, the oxidation number will decrease, and as you can see here, this atom or this ion is gonna gain a number of electrons, while in oxidation reaction the ion or the atom will lose such a number of electrons. So let us start with the formative assessment, page 607. Question number 1 says, what differentiates an oxidation reduction reaction from other types of reactions, such as precipitation reactions or acid-base reactions? So as we discussed, oxidation reduction reaction involves the transfer of electrons between atoms or between ions of an element, while as we know, precipitation reactions is kind of reaction that will happen in a solution where an insoluble product will form. For acid and base reaction, we know it's kind of neutralization reaction, which acid and base will react to form water molecule and salt. So I think question number 1 is clear enough for you guys. Let us move to question number 2. Question number 2 says, label each of the following half reactions as either an oxidation or a reduction half reaction. This question is so important, guys. Let's start answering it together. So for A, we have this reaction, and we can see, in order to decide whether the reaction is oxidation or reduction, we should pay attention to the oxidation number of this atom or this ion. Now, as we said, for oxidation reaction there will be an increase in the oxidation number, and the atom or an ion of certain element will lose the valence electron. So as we can see here, the oxidation number of this atom experience a decrease in oxidation number, and at the same time this atom gained 2 electrons. So what do you think? Is this a kind of oxidation or reduction reaction? Yes, guys, this is a reduction reaction. Again, reduction reaction will involve a decrease in oxidation number, and the atom here will gain a number of electrons. So here we need to write the answers. So for A, answer is reduction reaction. Okay. So now let us move, guys, to B. For B, is it a reduction reaction or oxidation reaction? Again, let us see what happened to the oxidation number. The oxidation number for sodium atom was 0, and then it increased to positive 1. And at the same time, you can see that this atom lost 1 electron. So what do you think? Is it a reduction reaction or an oxidation reaction? Yes, this reaction is oxidation reaction, because as we said, oxidation reactions involve a decrease in the oxidation number, and here the atom, this reaction will lose a number of electrons. So the answer will be oxidation reaction. Oxidation reaction. So now let us move to C. Here, what do you think, guys? Is it a reduction or oxidation reaction? What do you think? Here, this atom experienced an increase in the oxidation number. It was -1, and it became 0. So yes, this atom, or this anion, actually experienced an increase in the oxidation number, and at the same time it lost 2 electrons. So this is an oxidation reaction. Well done, guys. Okay, next, guys, what do we have? For D, what do you think, guys? Oxidation reaction or reduction reaction? Okay, well done. So again, the chlorine ion, or the chlorine atom, actually experience a decrease in the oxidation number, and at the same time it gained 2 electrons. So just as reaction A, it will be reduction reaction. Okay, next, guys, what do you think? For the sodium cation, there was an decrease in the oxidation number. It was +1, and it changed to 0. So the sodium cation here experienced a decrease in the oxidation number, and at the same time it gained 1 electron. So that's why this kind of reaction is a reduction reaction as well. Okay, guys, so for F and G and H, you will continue the same way. So I will leave it for you to check if you understood the concept of the oxidation reduction reaction, or if you didn't. Let us see. So now let us move to the next question. The question here says, which one of the following reactions is a redox reaction? To decide if the reaction is a redox reaction or not, we should notice or recognize if there is change in the oxidation number of each atom in these compounds. Okay, so let us start with A. Here we have potassium nitrate dissociate into potassium nitrite and oxygen. So now let us assign the oxidation number of each atom here. For potassium, guys, what do you think the oxidation number will be? As we say, the oxidation number of all elements in group number 1 should be equal to positive 1. So the oxidation number of potassium is positive 1. What about oxygen, guys? The oxidation number of oxygen is always or mostly negative 2. So now we have the oxidation number of potassium, which is +1, and for oxygen -2. What about nitrogen? Remember, guys, how can we assign the oxidation number of certain atom knowing the oxidation number of other atoms in a compound? This is kind of what? A neutral compound. And if you remember the rule we discussed about it, we say that the sum of the oxidation numbers of all atoms in a neutral compound is equal to 0. So according to that, we should make our calculation. 3 multiplied by -2 equal to -6 plus the oxidation number of potassium, which is 1, will equal what? Equal the oxidation number of nitrogen. So again, -6 plus 1 equal the oxidation number of nitrogen, and it will be equal to positive 5. So now we have the oxidation number of all these 3 atoms. For the potassium is positive 1 because it belongs to group number 1. For oxygen is -2, and we calculated the oxidation number of nitrogen according to the rule number 8, and the oxidation number was equal to 5. Now let us see how the oxidation number changed. Again, here for potassium it will stay positive 1. For oxygen the oxidation number is -2, but here we have 2 atoms of oxygen, so we need to again calculate the oxidation number of nitrogen. So we will use the same rule. The sum of all the oxidation number of the atoms in a neutral compound should be equal to 0. So 2 multiplied by -2 is -4, plus the oxidation number of potassium, which is 1, -4 plus 1 is -3, and it will go to the other direction, so to the other side. So the oxidation number of nitrogen in this case will be equal to 3. So now the oxidation number of potassium is 1, oxidation number of the nitrogen is positive 3, and the oxidation number of the oxygen is -2. What about the oxidation number of this element, guys? Oxygen element. Okay, it should be equal to 0. Why? Because always, guys, it's a rule that for any molecule in which the electronegativity of the atoms are the same, the oxidation number should be equal to 0. So the electronegativity, whenever the electronegativity of certain atoms in a compound are equal to each other, the oxidation number of this element should be equal to 0. So the oxidation number of the oxygen O2 is 0, the oxygen number of N2 is 0, the oxygen number of Cl2 is 0, and so on. Okay, so now, guys, we can see that there was a change in the oxidation number of the nitrogen atom in this compound. The nitrogen atom experienced decrease in its oxidation number, and that's why we will consider this reaction as a redox reaction. Redox reaction is a reaction that involves the transfer of electrons. So for A, obviously is considered a redox reaction. in the same or using the same way we will answer question B, guys. Here we have hydrogen reacting with copper oxide to give us copper solid precipitate and a water molecule. Again, the oxidation number of hydrogen will be 0. Why? Because we have similar elements, and we say that when the electronegativity of the elements inside a compound is equal to each other, then the oxidation number should be equal to 0. So oxidation number of hydrogen is 0. What about the copper and the oxygen in this compound? Copper, as we know, is in group number 2. That's why the oxidation number of copper should be positive 2. And oxygen, as usual, the oxidation number will be negative 2. So now what happened next? For copper, now you remember the first rule in our table here says that the oxidation number of any uncombined element is 0. So in this case, the oxidation number of copper, which is uncombined element, should be equal to 0. What about the water molecule? For hydrogen, it will be positive 1, and for oxygen minus 2. And here we can notice that there was a reduction in the oxidation number of the copper atom. That's why this reaction is also considered to be a redox reaction. Okay, guys, in the same way you may complete the other questions. So please try to find out. You already actually have the answers, but you need to practice them without depending on the answer that you have. Okay, guys, because I need you to practice the rules and the calculations of the oxidation number. So now let us move to the next question. This question is from the chapter review, question 17, and here actually we have the same question. Here you need to identify which reaction is a redox reaction and which reaction is non-redox reaction. Again, you need to assign the oxidation number of each atom or ion in these elements, and then you will see if there is any change in the oxidation number of these atoms, then the reaction will be a redox reaction. If the atoms or the ions in this compound didn't experience any change in the oxidation number, then the reaction will be non-redox reaction. So that's all for today, guys. Thank you, and see you inshallah tomorrow.